So before we move into the other two forms of a linear equation, we need to take a little detour here and discuss slope, because slope relates directly to linear equations as well. And this information is at the top, beginning at the top of page 64 in your textbook. It starts talking about slope and how we can find slope from different representations. Okay, so the first thing we're going to talk about is how to find the slope from a graph. Then we'll talk about how to find the slope from 2 points, and then how to find the slope from an equation. And you have all of these in your, you have this foldable in your notes already. So you'll be able to fill this one in as we go through the inside. Okay, so when you open it up, the top is discussing how to find the slope when we're just looking at a line that's already been graphed. So a graph has already been given, and we are going to be making or finding the slope of that line. Okay, so first thing you need to understand about slope as it relates to a graph is that slope represents a movement. Okay, now I'm going to put a point on the graph where I see the y-intercept, because it says pick 2 points on the line, starting from the y-intercept. So I always look for the y-intercept first, which is right here where it touches the y-axis. And then I'm going to find another point, and it doesn't look like it crosses perfectly in a corner of a grid mark until about right there. So there's 2 points. And what we're going to do is we're going to count how long it would, or how far it would be to get from one point to another. And we always start at the point that's furthest to the left. And then we have to determine what movements we have to make. So the way that we define slope is we make the first thing that we count be the rise. The rise is vertical movement, up or down. Okay. Then we have a horizontal movement. Do we have to move right or left? And that's called the run. Okay, so we always put the rise on top, and that's where we begin counting first. We count vertically first, then we count horizontally. So if I start from the y-intercept and I'm trying to arrive at this point here, I have to go down to get to it. Okay, so if I have to go down, okay, then I'm going to be going down and then to the right. Okay, so I'm going to start from the y-intercept. I'm going to count the rise and the run, and then after I'm done, I'm going to write that ratio or that fraction in simplest form. Now, this little Christmas tree thing you see here is going to be where we write in what happens when we try to do the slope. There are 4 possibilities. 2 of them we're going to talk about further later, but there's 2 of them that we'll talk about right now as well. We'll fill the whole thing in, but we just won't discuss everything until later. So when a line is graphed, in many cases it slopes. It might slope up or it might slope down. If it slopes up, we call that a positive slope. Think about it as traveling up a mountain. Okay, that's a positive distance. If the line slants down, we call that a negative slope. So you can write negative down the side. So if I'm falling down the mountain, that is a negative slope. Okay. Now there's 2 other slopes that we have to deal with, but we only deal with them when we're dealing with horizontal or vertical lines. And that is that if we have a horizontal line, it is a 0 slope, and if it is a vertical line, then it's an undefined slope. Sorry, let me just see if I can squeeze that in better. Okay, so if it's horizontal, it's a 0 slope. If it's vertical, it's an undefined slope. And we'll talk more about those. We have a whole page that you guys don't have yet, but you're going to see it here in a little bit. And I'm going to give it to you next week, a whole page on dealing with horizontal and vertical lines. Okay, but let's take care of this example. So we have our points on the graph. So the first thing I want you to recognize just is look at the line. Is the line, when I look from left to right, is it rising or falling? You should be able to tell that it's falling. And if it's falling, This slope is going to be a negative slope, okay? Now I'm going to count the rise, which is the vertical movement. So how far down did I have to go? 1, 2, 3, 4, 5 down to be across from that point. So that's -5. And then 1, 2, 3 to the right is the run. So the slope of this line is -5/3. All right, now I'm going to pause the video and then we're going to come back on a second video and find the slope using 2 points in case a graph is not given.